Hi, everyone, and welcome to today's webinar featuring Rotem and Kostas. We'll be talking a lot about GitOps. We're talking a lot about databases. Thank you for your time and attention joining us for today's webinar. We really appreciate it. For those who don't know, this is a series of webinars that we have available up at our octopus.com website. If you go to this URL, octopus.com/webinars, you'll find them there. We have a bunch of webinars that are coming up on the docket. So we have our Octopus 101 series coming up later this week. There are some new versions of this. We have time or geo-specific versions of this webinar. So if you happen to be joining from, say, the APAC, Asia Pacific region, or Europe, we'll have sessions for that. And you'll find all of these available up on octopus.com/webinars. The other location, of course, is those available up on demand at codefresh.io. So if you go to codefresh.io/webcasts on demand, you'll find a bunch of webinars that we've held in the past. Everything that we'll be doing today is live. You can ask your questions, up on the comments for those types of questions that come up. Rotem and Kostas will be answering them at specific points during the webinar. But at any time, you can go ahead and ask them, and we'll go ahead and get those taken care of. In addition to that, you can also check out a recording of this webinar after the fact up on our YouTube channels. You can either go to the YouTube channel for Octopus Deploy. You can see that we're going to be live here. This is depending on how you're joining us today. Or you can go to the Codefresh channel, which is at /Codefresh-CICD. So there we go. Awesome. So I will now exit stage left and turn things over to Rotem and Kostas for their presentation today. And just a reminder, if you have any questions, feel free to post them to the comments.
Okay. Hi, everyone. Thanks a lot for joining our webinar today about GitOps meets databases. So my name is Rotem. For the past 4 years, I've been the CTO, co-founder of a company called Ariga, maintaining an open source project called Atlas that we'll be talking about today. And with me is Kostas.
Hello, I'm Kostis. I'm a developer advocate at Codefresh, now part of Octopus Deploy, and I'm also a member of the Argo team, focusing mainly on Argo CD and Argo rollouts.
Perfect. So before we jump into GitOps and databases, I want to tell you about the first application that I ever deployed to production. It was a marvel of engineering, and I had bought a VPS, a virtual private server, from a hosting company here in Israel, and it had everything on it. It had on the instance a MySQL database, Nginx web server, Python backend application. The front-end stuff was served from the same machine. It was all in one, and I was super proud of it. I tried to visualize the project my team is working on today, a cloud-native application, and I couldn't find a way to put it in the screen. So what I did was I counted how many lines or how many resources exist in our Terraform module that represent this application. And I counted over 2,400 different components that we deploy just to have this one application. So apps today are much, much more complex than they used to do. And when we are talking about deployment, of course, our goal is to move fast. Our goal is people working on CI/CD pipelines, supporting application development teams to have them move fast, ship software, deploy multiple times a day. But the question that always bugs me is, for such a complex system with so many moving parts, how is it even possible to move fast on such a complex system? And to answer that, we can go back to a book that was published a few years ago called Accelerate. Accelerate is kind of the DevOps philosophy Bible. And in this book, the authors say something very interesting. In order to move fast, it should be possible to provision our environment and build, test, and deploy our software in a fully automated fashion, purely from information stored in source control. So if we want to do ops, we need Git, right? We need everything to be in this one source control repository, and we need some automation to be able to apply this information to our production environment. How do we do that? Well, the concept is called comprehensive configuration management, but the authors don't prescribe exactly what is the way, what is the tool, or what is the actual strategy that we're going to use to employ this. And to try to make this a reality in our industry over the past few years, two major schools of thought or strategies have evolved. One of them is called infrastructure as code. You may know this from projects like Terraform. And the other one that we'll be focusing on today is GitOps. And this kind of utilizes Kubernetes. And the idea is that we store all our resources as Kubernetes manifests in a Git repository. And we have some controller, some application that's responsible to continuously reconcile whatever is in Git should become reality in the cloud. So it's really a beautiful idea. It's a marvelous idea, and having built and deployed applications in things before GitOps, it's really fantastic, because in theory, it means that anything that we want to change or to apply to production is as simple as changing some file and hitting git commit. And if we want to undo something, to roll back a change, all we need to do is git revert. So we get this kind of very simple tool to control this very complex environment. Of course, there's a caveat, or there are multiple caveats. And as teams that try to adopt the GitOps philosophy and make it a reality for their applications and for the users, quickly discover that some things are not so simple. In the case of stateless resources like applications, containers, pods in the language of Kubernetes, things are really well thought out and solved in a very beautiful way. So for instance, when we're talking about rolling out a new version of an application, in Kubernetes, we have something called a deployment object. All we need to do is change some information about this deployment. For example, the Docker image tag that we want to deploy to our system. Kubernetes detects this, create a new replica set, a new set of replicas of this application, start to spin out instances of our new application version, run some health checks, make sure that the server is up, nothing is crashing. And once everything is good and running, Kubernetes goes on and destroys the old version, the previous generation of the application. At the end of the process, we made some change, presumably in Git. And at the end of the process, we have the desired state has been applied to our cluster, to our system. But if this works for stateless resources, what do we do about the stateful resources, like databases? And databases pose a unique challenge, and I'll try to explain why. What would happen if we applied the same strategy to our database changes? Before we answer that, just as a refresher, what do we mean by database changes or database migrations? When our data models change, which should happen all the time, as that software is never done and we need to ship new features to our users. The data model change. So for example, if we have a Python class representing a user and we want to add some attribute to track this user's birthday date. If we want to make this change to our system before deploying the new version of application, we have to update the database schema. Typically, applications are backed by some stateful storage. This stateful storage is usually a database, and this database has a schema. So we need to add the birthday column to the user table before we can deploy the new version of the application. Otherwise, when we deploy the new version of the app, it will issue queries looking for this user's table, this birthday column, and these queries will fail. We have downtime, and nobody is happy. So before rolling out versions of our application, new versions, we need to make sure that the database schema is all set. So what would happen if we applied the same strategy that we do for pods, for compute, for the application containers for our database? So step one, spin up a new database with a new schema. Step two, make sure that it's healthy, run some queries, make sure that they don't fail. And step three, kill the old database. Of course, this would get the job done, but our job security would probably not be so safe. Our managers would not be pleased that we just nuked our company's data and everything is lost. So don't try this at home. It's not really a good idea. So if a naive approach of spinning up something new, killing the old once that's healthy is not going to work, we need some specialized tools. And over the past 2 decades, we have a group of tools called migration tools. These are tools that our sole responsibility is to migrate the database schema from the previous version to the next. And being in this space for the past decade or so, and working on a schema management tool for the past 4 years, I've reviewed hundreds of these tools. And to make a long story short, the vast majority of them work in a very similar way, where you define a migration script. So if we want to add some column, we create some script that has instructions, what commands we should issue to the database to get the schema where we want it. Now, in some tools, this is SQL, sometimes it's JavaScript or Python or XML, God forbid, and we usually need to supply the up migration, how to upgrade the database, and the down migration. Not going to get into rollbacks and down migrations today, but this is typically how these tools work. So we have this kind of imperative set of instructions, which is very different than the way we showed that Kubernetes works and that reconciliation loops work in declarative systems. So how do we fit these scripts, basically, into our shiny GitOps declarative system? Well, if we look at the Argo CD documentation, we see that Argo suggests that in order to run database schema migrations, in order to run these migration jobs, we should use a pre-sync hook. And let me explain what that means. So what we would do is we would create a job in Kubernetes. A job is basically a container, a pod that runs once, and then once it's finished, it's terminated and deleted from the cluster. So we want to create this one-time container that will run and then be deleted. We add some annotations telling Argo that this is a pre-sync hook. Basically, it's something that should happen before we sync our application. And we define the container. We usually will build some custom container. The container will contain the migration script, so the SQL code that we want to run on the database, and whatever tool we are using to apply these migrations to the database. How is it supposed to work? Well, as a user, I change the git commit, the new version that I want to deploy. Argo CD detects this change. It sees that it has a pre-sync job, so before upgrading the rest of the resources, it will provision a job on the cluster. The job contains the migration tool upgrades the database, and problem solved. Everybody is happy, and we can go home. However, if you came to this talk today, perhaps you recognize that things are not as simple. And if you know Victor from DevOps Toolkit, really great YouTube channel about DevOps and platform engineering, Victor says, we can wrap existing schema management solutions into containers and run them in Kubernetes as jobs, but that is silly. That is not how we work in Kubernetes. So the big question that we ask today is, can we do better? And Kostis, what do you think? Can we do better?
Yes, spoiler, we can do better. Thank you, Rotem. Of course, we can do better. But I want to talk specifically about, what people are doing right now. So if you look at several companies, they move into GitOps or Argo CD, and they try to map the building blocks of Kubernetes into database migrations, and this doesn't work. So they say, oh, I have init containers, let's do the database migration there, or I have a Kubernetes job, let's do a database there. And specifically for Argo CD, they find this documentation piece that Rotem also found, and they try to do database migrations in pre-sync hooks. And this works, but doesn't work as always. And this is why we recommend using a GitOps operator, as we will see today. And how do I know that it doesn't work? As I said, I'm part of the Argo team. So one of the things I do daily is go into the Slack channels and look at what people are asking. And they are always asking the exact same question. How do I do database migrations with Argo CD? Or I'm trying to do database migrations and I'm trying with pre-sync hooks and it doesn't work. And why it doesn't work? Because yes, the first time I do a deployment, it works just fine, but then is another sync operation for another reason. And either I don't want to run the migration again, or the migration runs, but it's too slow, and so on and so on. The other problem you have there is that if you try to do this pattern, it's a black box, like Argo CD runs, and the pre-sync hook is a black box for you. You don't know what is happening behind the scenes. You don't know what is happening in the database. You don't even know if the migration has finished successfully or not. So this is a problem right now, and everybody is looking for a solution. I also want to go back a bit, some steps, and talk specifically about GitOps. And I want to clarify this because several times people don't even agree on what GitOps is. So if you're not familiar with this, there is a GitOps working group. You can see the webpage here. It's opengitops.dev and specifically defines what GitOps is. So most people are familiar with the first two principles, that if you're doing GitOps, you should have a declarative way of saying what needs to happen and also version your files. But most people are not familiar with the last two principles, that you should pull your changes automatically and you should do this all the time. So this is something that is satisfied by Argo CD and Flux and other GitOps tools, but it's not how most companies might work today. And I'm saying this because if we are talking specifically about application deployments, most people, know how Argo CD works behind the scenes. So we started with applications in the dark ages, and we do things by clicking stuff, then writing scripts. Then we got Kubernetes, and we had a nice way of using declarative files. And then finally, we are in Argo CD, and we have a GitOps solution. So for applications, let's say we are happy. But if you're looking at databases, people don't know yet how to work with databases and GitOps. And actually, today's presentation is exactly about this, how to do GitOps with databases. And when I'm saying GitOps, I mean the proper principles of GitOps. So we are far behind in databases. And I see this all the time with companies. Like I ask them, how do you deploy right now? And they said, hey, we have Argo CD. We deploy 4 times per hour. It's great. It's the best thing ever. Okay. And then I ask them, how do you do your database migrations? Oh, we still do this manually, once per week. And this is really frustrating because, the bottleneck is always the slowest link. So if you're doing database migrations once per week, then you're blocked by database migrations, even if you have the best process possible for application deployments. So instead of working, with GitOps just on applications, we also want to work with GitOps for database migrations. And this is exactly what we're going to see today and in the demo as well.
Great. Thank you, Kostis. So this problem actually is not completely unique to database migration, and it reoccurs whenever we have a stateful resource. Because as we shown, for the stateless resources, the Kubernetes primitives work just fine. Service, persistent volume claim, pod, deployment, replica set, ingress works really well. But for stateful resources, we need specialized software that understands the semantics of the target system and can automate the work for us. And for this, the Kubernetes community came up with a very cool design pattern, something that's called an operator. And an operator basically is comprised of 2 important parts. One of them is a custom resource definition. So a custom resource definition basically extends the Kubernetes API and gives us an API to define these resources. So like a database schema or a database instance, things that are stateful that we want to manage through Kubernetes. And the second half is a controller. A controller is a specialized piece of software that runs on the Kubernetes cluster and listens to changes in objects of this specific type. And this application encapsulates the logic that is needed in order to manage these resources in practice. So in the context of our talk today, I want to talk about the Atlas operator. It's one of the, I think, most interesting projects that I had the pleasure of working on in the recent years. And this operator is a purpose-built operator for managing schema changes from within Kubernetes. You can find the source code on GitHub and try it out today. And we'll be describing it shortly and showing a demo of how this thing works. So the operator actually wraps another project called Atlas. And Atlas is a database schema management tool that we are working on in Ariga, in my company. We open sourced it in 2021. It's become very popular in the industry. And Atlas is the engine inside the Atlas operator. And the way that it works is that it provides the operator with 2 key capabilities, 2 key components that are critical in order to have an operator to manage your database in production from within Kubernetes. The first one is a sophisticated migration planner. So Atlas actually understands migration files, it understands database schemas, it understands the target database that we are connecting to, and it can calculate diffs and plan migrations automatically. The second part is a migration analysis engine. So schema changes, migrations are notoriously risky. If you're not careful, you can accidentally drop data, you can create a breaking change to break your API, you can lock a table for a long period of time. So we also need a safety mechanism that if we trust the tool to do things in an automated way, it needs to have some guardrails and safety checks in order to make sure we don't shoot ourselves in the foot. The Atlas operator introduces two types of custom resources. The first is called an Atlas schema. An Atlas schema is about fully declarative schema management workflows, which means that we don't have migration files. We don't have these alter table statements. The only thing we provide the operator in this workflow is a connection string to the database and some representation of the desired state. So whenever we change this state, the operator detects this, automatically plans the migration, and applies it if it's safe. The second kind of workflow that we will be demonstrating today is the version migration flow, and this uses the Atlas migration custom resource. Also here we provide a connection string to the database, and we need to provide the directory of files, the migration, the classic approach that you probably know and used in the past. We can provide it as a config map, we can provide it in a remote schema registry, and in a bunch of other ways. But in this case, the migrations are pre-planned, and the operator is only responsible for applying them in a Kubernetes native way. So some key features that you might want to know about that are interesting. First is lint policies. So we mentioned a migration analysis engine. So Atlas can look at the current state of the database, can look at the proposed migration, and can tell you, based on policy that you set, if you're going to do something risky. So safety checks to make sure that stuff doesn't break. Diff policies, sometimes you want to control the way that migrations are planned. So for example, if you're using PostgreSQL, you might want to say, I always want indexes to be created or dropped concurrently, because otherwise Postgres will lock the table. If it's a large table, it's downtime. So we want some knobs to control the way that Atlas actually plans the changes. Down migrations, many tools, as we have shown in the introduction, ask that you pre-plan the down migrations in case you roll back. With Atlas, you don't need to do this. Atlas knows to understand the up migration and automatically plan the down migration for you, even if it was only partially applied. So if you had 1, 2, 3 statements, only 1 and 2 were applied. If you roll back, it will only try to roll back the statements that were applied successfully. Pre-migration checks allow you to make assertions about the target database, so only drop this table if it doesn't contain any rows, or only drop this column if it's completely empty. So it gives you another way to control and limit negative impact in these risky deployments. And finally, super important to our talk today is that we have contributed to the Argo project a small contribution that allows Argo CD to understand the semantics of Atlas. So Argo CD understands when a migration is done, and then you can use this in something called sync waves. So you can say, Argo CD, first finish the migrations, only when they have finished successfully, go on to upgrade the application. So you're not stuck in a state where the database is incompatible with the application. And I take it back to Kostis.
And time for the demo, finally. Yes, so today we are going to see a demo with the Atlas operator that Rotem already talked about, and Codefresh. So just to make sure that everybody's on the same page, the 3-minute pitch about Codefresh. It's an enterprise deployment solution based on Argo CD. It's Argo CD behind the scenes. It has several features that are specific for enterprises. For example, support for Argo, a security distribution of Argo, and several things like that. But I want to talk specifically about the features, like why would you get Codefresh over Argo CD? First of all, Argo CD is a great tool. As I said, I'm part of the Argo team. Codefresh contributes to Argo. Right now, the actual Actually, the last Argo CD release, if you go to the Argo blog, was done by Codefresh engineers. So we love Argo, but we think we need to extend it with things that enterprises need. So one thing that Argo is missing is the concept of environments. Argo CD doesn't know anything about environments. It knows clusters, it knows Git repos, but it doesn't know anything about environments. So when people usually adopt Argo CD, they make this hack where they start naming the applications with a specific naming pattern. So here I have 3 applications, and if you look at them as a human, it's obvious that accounts QA, accounts prod, and account staging is the same application deployed in 3 different environments. But this is just for humans to know. If you ask Argo CD, this is 3 different and non-related applications. So we said we don't want to do this. So in Codefresh, we have proper ways to support environments. So you can actually mark some clusters or set of clusters and say, these clusters are not random. They are my production. These clusters are staging. These clusters are QA. And then here, if you can see, I have the exact same application accounts where Codefresh knows it's the same application. It's the application called accounts, and it's deployed in 3 different environments. And then I can do fancy stuff like promoting the application from one environment to the next. So here I have an example workflow, which is not possible to do with vanilla Argo CD, where I've said I have 4 environments, my dev, my staging, my QA, and my production. Developers can only deploy into dev. That's the only thing they can do. And then they need to promote to staging and QA in parallel. And only if things succeed in staging and QA, then you can go to production. And you see in this particular example, something has gone wrong into QA, and developers cannot move the application to production. So this is something that Codefresh offers on top of Argo CD, this visualization of environments and also the workflow. And the other thing regarding visibility is, again, that if you ask Argo CD, it only knows container images and nothing else. It knows that this is a container image and it's deployed there, but usually developers want some extra information regarding their application. So you might ask, okay, this is deployed, but what was the result of unit tests? Or has this image passed all our security scans? Or what features does it contain? Here you can see an example where we have integration with Jira, so you can actually see which Jira features are deployed to which Argo CD environment. So if you have a project manager and they are always asking you, hey, I'm interested in Jira feature 1, 2, 3, 4, 5, where is it? Is it in staging? Is it in production? Argo CD cannot answer this, but Codefresh can answer this. So these are the extra features that we have. This presentation is not about Codefresh, it's about the operator. So let's see both of them together. So I'm going to start and I'm going to show you the initial state before I do everything. So this is Codefresh. I have a sample Kubernetes cluster, and just for the sake of speed, the Kubernetes cluster is already there. I have a database there running. So I have a Postgres database, which is already deployed. In this example, just for simplicity, it's in the same cluster, but as you can imagine, it could be anywhere else. I've also installed the operator, and the magic thing for today is that I have this Atlas migration project. So this Kubernetes resource doesn't actually represent a database. It represents the connection between Atlas and my database. So my database is controlled by Atlas, and this is how I make the distinction. This is the YAML file that Rotem was showing before. It's a custom resource offered by the operator, which is called Atlas Migration, and it makes the link between Atlas and my databases. And just for the sake of demo, if you're familiar with Argo CD, I've set this to autosync off, so nothing will happen unless I approve it, okay? Maybe in a real production system, you would have it on, and as soon as any change happens in the database and with the operator, Codefresh would automatically take care for this, but because we want to look at things in the demo, it's off. I'm saying this because you might see me click buttons for approvals and to synchronize stuff. So that's the initial state. And because we are doing GitOps, everything is in Git. So here I have the exact same things. This is my database deployment, which Codefresh has already synced. And this is my Atlas migration, which we have synced already. And how do I know what is in my database right now? So this is where Atlas comes in. Here I have the live overview of the Atlas cloud, where it shows me a nice overview of the schema that is contained in the database. And I want to stress out that this is like real information. This is not just a diagram I created from a file and it shows what might be in my database. this is exactly what is in my database right now. You can see the columns. We are going to talk about, the CI runs and everything. But for me, the most important feature here is the integration with the database itself, where Atlas says to me, right now, your database is at the latest version. So what I look at the dashboard here is also what is in the database. Remember the discussion about having visibility, what happens in the database. So even before I start doing anything, you can see that with Codefresh, I have visibility regarding the applications themselves. And with Atlas, I have visibility regarding the databases. So I can answer all questions regarding, what application is deployed where, what container image is deployed where, if it has passed security scans, or what my database has. So that's the initial state. Now let's do a change. Okay, I'm a developer or a DB operator, and I want to do a change. And again, because we are following GitOps, in the same repo, I have also my schema and my migrations. So these are my existing migrations that you have seen, that you might have seen, if you're in a big company. And here I also have my schema of the database that explains what I want to do. And I want to do a change. And remember our graph about GitOps principles, I want to do the change in exactly the same way as I would do it with an application. I want to give database migrations the same effort and the same attention as application changes. So if you ask a developer what they do when they change a feature, they make a change, they create a new branch, they create a pull request, then in the pull request can have some checks, maybe somebody approves that pull request, and once they are happy, they merge the pull request, and then they kick a deployment process, which in our case might be Codefresh or let's say Octopus deploy or something like this. And if you do this process for applications, you would want to do the same thing for database migrations as well. So we are going to follow the exact same process for database migrations. So I have here my code, and I'm saying, okay, what do I need? This is a very simple table. My previous change was that I added upvotes for posts, and now business says we also want downvotes for posts. Okay, so I'm going to add this. And coming back again to the GitOps principles and, the way declarative configuration works, even though Atlas also supports, plain SQL files, here as a developer, I'm just going to say what I need. So I need a new column there for posts. And then I'm going to say to Atlas, hey, I told you what I need. Now go and create all the migrations file for this. So I run this.
You need to save the...
Yeah, I need to save it. I run this, and Atlas does the magic. And then there is a new file here that says, in order to reach your result, I need to add a column. Okay, so I've done this. Now I'm going to do what I normally do for an application release. So I need to create a new branch. So I'm going to create a new branch called new column for downvotes. I'm going to add everything and say new downvotes column. And then I'm going to push this to new column downvotes. So I did the exact same thing as a developer would do for a feature. Okay, so far I haven't done anything really strange, and I now can come to GitHub, and again I do the exact same process. I just create the branch. Now I want to create a pull request where maybe I want some automatic checks, or I want maybe another developer to view this. So I'm going to compare and create the pull request. And I'm going to do it on my own. And I'm going to create the pull request. So if you're familiar with how code works, usually here you have some kind of CI process where maybe there are some integration tests, some unit tests, or some security scans. And now I'm going to do the same thing with Atlas. So I told Atlas, hey, I'm proposing this set of changes. This is what I want to do. And Atlas starts an automated process that we can see where it's going to check my changes and say, yes, this looks good, or it doesn't look good. So today I'm going to show you the happy path scenario where, everything is fine. And after I do the pull request, there is also a comment by Atlas, where it says everything looks good. But you can imagine I have, failures here. Maybe I did a mistake. Maybe what I did was not safe. And Atlas would present a warning there. I can also see the run here in the CI runs. And, it says to me that everything is fine. So now I can also give this pull request to another person, like a human, to validate it and say that everything is fine. Let's assume that everything is fine. And I merge the pull request, and now it's in master. Okay. So this, let's say, concludes the CI part of the process. If you were doing application development, now you would have a container image that is pushed somewhere in your registry, and then you need to deploy it. But you have seen that until now, I didn't do anything really different than application deployments. So the magic thing now happens on how we deploy this to production, to our database. So first of all, again, we can see, what Atlas is doing here. And for me,
the refresh cost is.
No, I want to show this diff also. So I can see here all my diffs as well. So I can select the previous one, and it tells me that right now, if I scroll down, you have added a downvotes column here. So I can see not only, what is the current state of the database, but also the history of the database. And here, for me, this is the magic moment. It clearly says to me that, hey, your database is not in the latest version anymore. You're one version away from latest. Because for me, at least, in many developer teams, sometimes the first question is actually understanding what version is actually running in the database. And finding this in a big company might take, even 1 hour to understand, what schema you have and what happens in the live database. So for me, this is one of the major selling points of Atlas, that I have an actual system that tracks for me what's in database and what is in my schema. Okay, so now I want to deploy this to my database. And if we look at the GitHub repo, one of the things that I have in the migration is that I have defined specifically which version I want. So here I'm saying this database migration goes to this database, and I want to take this particular tag from my database. So this 2D stuff comes, if we go into Atlas from the tags, and you can see it's the previous one. While now I don't want the previous one, I want the latest one. So I want this. And, this is just a demo for today. Obviously, you could do other stuff, but just to show things happening in steps, I'm going to manually say, no, let's go to this hash. So because, again, we are doing GitOps, I'm just going to edit this file in Git, like I would do in developer, and I will do it directly in master. But again, in another company, you could have a pull request even for this thing, like not for the database change itself, but for going into the next database. And yes, I know I didn't take it. So I'm going to do it straight in master, but as I said, you could do it on a pull request, and I would say go or maybe add new column and add this. So now ArgoCD or Codefresh takes over, and here in my demo, if I had, this autosync on, everything should run automatically. But because I want to show you how things happen, I'm going to say refresh to Codefresh, and Codefresh will instantly understand that there is a change. So it will tell me, hey, your Atlas migration is not now the same as what you have in Git. In Git, you did something else, but in cluster, you have something different. One of the big selling points of Argo CD and, of course, Codefresh is that the agent that you have in a cluster is bidirectional. So not only it looks at, Git and transfer changes to the cluster, but it also looks at the cluster and compares it with Git. So now I said, okay, I know what this change is, and I'm going to synchronize it, which is, again, a way to say, if you're not familiar with Argo CD, I want the cluster to have the exact same thing as what is implied in Git. And I'm saying synchronize it. So now I did things manually, but if I had set this autosync on, this should happen automatically. So now everything is green, and now Codefresh says that everything is synced. And as soon as we finish, Now the operator runs behind the scenes. Remember, I have the operator controlling my database. It's going to take over the change. It will apply to the database whatever needs to be applied in order to reach the version. Now the deployment has happened. And if I refresh here, again, we will see that now we are at the latest version. So as a developer, again, I have the guarantee because of GitOps that what I have described here is in my database, and I have this column there, because I can bet that people, in order to have this information, actually connect the database with the CLI and check that the column is there. You don't need to do this anymore. You have Atlas doing this for you. So this combination of having, Codefresh for application visibility and Atlas for your database migrations not only give you a great overview on what is happening behind the scenes, but you have a uniform way of dealing with everything. So you can see I did all my changes just by committing Git files and creating pull requests in exactly the same way as I would do with a feature. So that's it for the demo.
Perfect. So as we mentioned before, the common way most people doing migrations through Kubernetes actually use either init containers or precinct hooks, but basically they just execute some job or some container that runs once. And as when you do this with the operator, then you do it the GitOps way, and you tell the Atlas operator, this is the version that I want to be out there. And it's now the operator's job to make sure that it does what needs to be done in order to get to that version. This means, by the way, that contrary to something that basically is not done with jobs, the operator can even understand the direction of the migration. So let's say we are now deploying a version that is lower than what is currently deployed in the cluster. The operator knows it needs to run a migrate down command and not a migrate up command. So when we say that the operator understands the semantics of the migration, it knows to look at the target database, what the current version is. If we're rolling back, then it has this information. Additionally, because the operator understands databases, it has access to the information schema. If we need to, for example, in declarative migration, do something to reconcile some drift that happened because of a manual change to the database, the operator is able to do that for both declarative and version flows. Migrations, super scary to most people, but if you have a tool that watches your back and does safety checks and applies policies for you, I think teams tend to move much faster. And one of the interesting things we see with teams that adopt this is that they start being much more nimble with their database. So doing tens of database schema changes in a month is not uncommon, because it's not a headache. It's not something we say, oh, this is scary, let's do this very carefully once a week. It's something that we can just be much more agile with our development. And also, in some cases, we don't have this in the demo today, but you can define thresholds where Atlas stops the automation and says, okay, this is an edge case that needs the attention of a DBA, someone, and it's in our experience, it's much better to not start a deployment that's going to be problematic than try to deal with the fallout. So all of this is stuff that you get once you adopt this different mindset, which is not we're going to run a script and hope it succeeds, but instead we have some component that understands the semantics of the change and have it automate and drive the changes. Key takeaways. For true GitOps, you need to solve both the application, the compute, and the database. If you leave migrations to be done manually, as Kosti said, the weakest chain in the link determines the strength. And in our case, this will really slow down your team, and you will end up not reaping all of the benefits of the automation work that you did. If you're using Argo CD, make sure to put migrations in a separate sync wave, so you don't have a situation where the database is incompatible with application, run migration first. Deal with failures up front. Okay, don't just run a job and hope it succeeds, and if it fails, hope that the retry solves it. It will not solve it. Use something that can understand failure and help you in times of trouble. And thanks a lot for your time. As a call to action, welcome to try Atlas. You're welcome to use and look at the Atlas operator. It's open source. You can look at it and try it today. If you're interested in using Atlas or Atlas Cloud, in our website, there's a link to our Discord server. We have a community of over 1,500 database, DevOps, software engineers that are really into this stuff, and we really love to have you join us.
Yes, on the Codefresh side, we have the #1 GitOps certification, and I want to stress out this is just Argo CD, not Codefresh. So it teaches you the basics of Argo CD. We have over 23,000 students. It has 3 modules: beginner, intermediate, advanced. The advanced was just released. And if you're interested in Codefresh GitOps, that is the link. If you're not interested in Kubernetes or GitOps, now Codefresh is part of Octopus Deploy, and Octopus Deploy is also a deployment solution that can deploy to things outside of Kubernetes. So if you're using virtual machines, Octopus Deploy can do this as well. And we have questions.
We do. Awesome stuff. So first and foremost, thank you, Rotem and Kostas. Great presentation. Certainly learned a lot, which is awesome.
Thanks for hosting us.
If you guys have a question, feel free to post it into the comments wherever you're viewing this from. We're going to go through some of the questions here. So Tom asks, does it work with non-production databases as well? For example, a developer database or dev database associated with the branch for testing.
Sure. So Atlas is first and foremost a local development tool. So it has lots of commands that you can use to prototype things really quickly. We have a whole framework for writing and running unit tests. So you can do things like TDD for your database logic. You asked about temporary branches or environments. Very common to see teams build promotion flows with Atlas, so you can have a change, test it in some branch environment, and have the flexibility that you need for a temporary environment, and have more strict policies for your production stuff. So you have the control of which kind of policies you want for every kind of environment. Hope that answers the question.
Awesome stuff. So Nicholas asks, what database engines are currently supported? And if not currently supported, are there plans to add Snowflake and or Redshift? And then Ariel said that Redshift is supported and Snowflake is on the roadmap.
Yep. So in terms of engines that we support today, Postgres, MySQL, MariaDB, Microsoft SQL Server, SQLite, ClickHouse, Redshift. We're working on an Oracle integration that will hopefully be out in Q1, and Snowflake sometime next year.
Srinivas asks, does it also apply to the cloud deployed instances of a database?
Sure. So great question. Atlas doesn't care where your database is running, as long as it has network connectivity to the database. Very large amount of our customers use RDS or Cloud SQL on GCP. So as long as you can express the connection to the database in a URL, in a connection string, and wherever you're running Atlas has a security group rule or network access, you can use a SSH tunnel, whatever you need, then sure, Atlas can run on cloud deployed instances.
Fantastic stuff. Just a reminder, folks, you can check out all the links that are available here on this slide. Also to remind you, if there's anything that you happen to miss during today's webinar, feel free to check out the recordings, which will be available on both the Codefresh and Octopus Deploy YouTube channels. This is me tap dancing, waiting for time for other people to pose questions. I don't think there are any other questions. So Rotem, Kostas, thank you very much for your presentation. Great stuff, learned a lot. Yep, don't see any more questions here, so we'll go ahead and end the stream. Thank you very much for your time and attention. Really appreciate it. And
thanks a lot.
Thank you.
Until next time, happy deployments, everyone. Take care.